Thank you guys for coming. This is Epsilon Pi Epsilon. This is part of the UPE Make program. You guys are members, so I really appreciate you guys coming here to the workshop. It's going to really help you once we get to further down in the semester and once we start giving out those certifications, or not certifications, but certificates, as well as recognition for all the workshops that you guys have gone to. For the workshops that we have for the rest of the semester, we have Raspberry Pi workshop. That's going to be on November the 5th. So that's going to be in about 3 weeks, maybe. And that's going to be a more basic Raspberry Pi workshop. What we're going to be doing is we're going to be using a Raspberry Pi to program an LED strip so that we can make it do different types of light shows. And ultimately, my goal with that workshop was to create a nano leaf, which is what we're going to try to do. And then we have the Raspberry Pi Advanced workshop, which is going to be using the Raspberry Pi so that we could create an in real life ping pong game. So basically, you're going to have two potentiometers that are going to be communicating with the Raspberry Pi so that you could play a pong game with the potentiometers. So that's going to be also a little bit more advanced, also because we're going to be using the SSH. So that we could go directly from the Raspberry Pi on our computer. We don't have to connect it to a monitor or a keyboard or all that stuff. But that's for later on. Once we get to that, I'll explain that in more detail. For our social medias, this is our social media if you're not following. If you guys ever do work on some of the projects that we do during these workshops, you can go ahead and post it, and they'll make sure to repost it as well. So if you want to maybe get more followers or get recognition for the stuff that you're doing on campus, you could do that. And yeah, this is the 3D modeling advanced workshop. It's not going to be too advanced to the point where you're going to get lost, but it is going to be covering a few concepts that we didn't cover in the first workshop, but you are going to be using those basic tools that we learned for this workshop as well. So if you haven't downloaded the Fusion, make sure to download it. What we're going to be learning today, we're going to be learning how to use simulations. And then we're going to be also looking at those different stress metrics that the simulation is going to give us. We're also going to be able to make an animation out of those simulations, because sometimes whenever you put strains on these models in these simulations, you have some sort of displacement. And there may be a case where you have to show those animations to your worker, your boss, if you're working in an industry where you have to use 3D models. We're also going to be using the T-spline with topology. So that's going to be using the freeform tool and creating a lot more structured but unstructured models. So it's not going to be specific measurements. It's going to be more based on what it is that we're trying to build. And it's going to make it a lot easier with the freeform tool, because we have ways to merge different sections of the model. And you'll see when I get there. But just a recap, if you guys don't remember from the first workshop, we have the toolbar on the top. You got the back and front with the save. For the data panel, we have the cube, the view cube. So if you want to rotate around the model, you could also do that with your mouse and your keyboard, or with your mouse pad, but it is going to be a little bit harder with your mouse pad. You have the timeline on the bottom. This is really useful whenever you want to go back to a different part of your model, if you might have messed up or something, or changed something that you realized later on that didn't work out. And then again, like I said, the navigation with the scroll, you scroll with the mouse wheel if you want to zoom in and out. If you click down on it, then you'll be able to pan over the model. If you click shift and hold down the mouse button, or the middle mouse button, then you'll be able to orbit. And if you have the mouse the trackpad, then you could follow these instructions right here to do that. I'll try to go a little bit slow, and make sure to let me know if I am going a little bit fast, so that I could maybe slow down, or if you need me to explain something, I could explain that for you. But one of the main concepts that we're going to be using during the workshop is a simulation. So for the simulation, we have this specific toolbar. I'm going to go ahead and explain that a little bit for you. So the study is going to give you the different types of simulations that you could create. There's a lot of different simulations. There's ones that include thermal, There's ones that are only force. So I have another slide that explains all those different simulations. But we also have simplify. And what simplify allows you to do is that if you create a model and you want to maybe remove the fillets from that model to see if that would impact the simulation in terms of maybe making it more safe or maybe making it more structured, you could do that without changing the actual geometry of the model that you created. And I'll show you what I mean when we get there. We have the materials, which will allow you to give the model that material characteristic so that when you do run the simulation, it will take that into consideration. Your constraint, which is where you will put a specific constraint on the model. Let's say, for example, we have a wall mount with screws. Those holes where the screws are going to be going are going to be the constraint. We also have loads, which is where we put the actual force that's being applied onto the models. And we could also change the metrics in terms of how much pounds or newtons we're putting. We have contacts. So whenever you have a model that uses different contacts, you could take that into consideration when you are creating the simulation. But in this case, we're not going to be using any contacts. This is display. This it just shows you the mesh of the model, which is like the geometry behind the model that's being used when the program's using or calculating how the simulation is going to turn out. Manages us for the settings of the whole model. This thing right here, this icon right here, is going to allow you to check to see if you are ready to solve the model. Solving the model is basically using that processing power of Fusion so that you could find out if there is displacement, if there is issues in the model that could maybe be better and things like that. And then just results will show you the different results that you got from that simulation. But to talk to you a little bit about the types of simulations, we have nonlinear static stress, which is things that tend to bend more. So in that, you have to use different algorithms and formulas that Fusion uses so that they could get the results for that. You also have event simulation. So whenever you have a model that's in movement, you could take those different velocities and time that it takes to do those movements and see what's happening to it. Similarly with modal frequencies, it's basically having different amounts of force in the variety, in the time-based aspect. So from some point in time, you're going to have more force than in another, basically. You also have cooling and thermal. So the Fusion is really good in that it gives you a lot of different resources and tools for whatever it is that you're trying to do. So if maybe you're making the PCB and you want to see if the temperature is going to maybe do any damage to the hardware, you could check that. So let's go ahead and start with Fusion. So go ahead and open up Fusion if you haven't already. And we're going to be basically making this model. This is a wall mount. And then we're going to be putting the force on the top and seeing how that impacts the stress of the model or the actual object. And then we're also going to see what happens when we put a support. Obviously, it's going to be a lot more structured, and we're going to be able to see that with the results. I'm recording, right? Yeah, I am. So let's go ahead and start by creating the model. We're going to be using this drawing right here to make that model. It's a wall mount. So for the thickness of the side is going to be 0.5, but the whole thickness from length and width is going to be 4 inches. But I'll go ahead and follow you guys through this. So just go ahead and open up Fusion. I would tell you that if you don't like this white background, because I know I don't, you could go down here to display settings and go to environment and click on gray or dark sky, and it'll change it to dark mode, except for the top, obviously, but it's a little bit better than it was before. So let's just start by creating a sketch. Again, if I go too fast or if you need me to explain anything, let me know. And we'll start off just by creating a box or a square that's a 4x4. So you could click on the middle and then create a 4x4 box. Again, if you want to put them when you're creating the square, you could click on your number 4 on your keyboard and then click tab, and it'll go to the other parameter so you could put it. From this point, you're going to finish the sketch. We could also make those other sketches here, but I just found it a lot easier to do it this way. And then once you finish the sketch, we're going to extrude it. So when we click on extrude, we're going to be extruding, as you can see here, by 0.5 inches. If your Fusion is in a different units, then go here to document settings and then click on units and change that to inches. And also make sure to set it as default because all the models that we're going to be creating for this workshop are going to be in inches. So now that we're there, we're going to go ahead and create another sketch on top of that square. It's going to be a rectangle, as you can see here, and that rectangle is going to be 0.5. So you could put 0.5. And then we're going to finish sketch, and then we're going to again extrude that out. This extrusion is going to be 3.5 because since we're doing it 4x4 and this is 0.5 right here, this has to be 3.5 and so that it could be similar or congruent. And we're going to make sure that we join it. We don't want to make a new body. This is going to be a whole structured model. Okay. So from here, we're going to go ahead and make the holes that we're going to use to put those constraints of the screws that we would be putting into the wall. And how we're going to do that is we're going to create a sketch and we're going to put it on that face, on this face right here. And since we want it to be in the middle, we're going to be using some construction lines so that we can make sure that it is in the middle. So right now you could just put it wherever, and then we'll make sure to put the dimensions so that we could make sure that it is in the right location. So just do 1, 1, and 1 like that. And then we're going to be using the sketch dimension tool to make sure that it's the same amount from the sides. So we're going to have it be 1 inch from the sides. And then for the middle one, we're going to make sure that it's 2 inches. So I got it automatically, but from the middle to the bottom, 2 inches. So now that we have that, what we're going to do is use the whole. All right, so the issue with what's happening here right now is that we're not recognizing any point in this intersection. And we want there to be a point there so that we could put the hole that we're going to create. So what we need to use is the create point and then make it so that there is a point at that intersection. If you don't, then it won't be as accurate as you would like it to be. So once we do that, we could finish sketch. Now we're going to use the hole method or function or whatever, a tool. And then we're going to click on those 2 holes that we're going to be using. Now, if we look at the sketch that we have here on the left, the outer ring is going to be 0.4 inches diameter, and then the inner is going to be 0.18. Something to mention is that for the hole type, we're going to be using a countersink, and then for the hole tab type, is going to be simple, and the drill point is going to be flat. Ideally, this is basically, if you've ever used or if you ever seen those hinges that are used for the doors, we want to create those similar holes that use a screw that doesn't necessarily screw into the part that we're creating. Obviously, this is metal, so we wouldn't want to screw into this. We're just going through it and holding it onto the wall. So we're gonna make this one right here. Oh yeah, this is gonna be 0.5, and then this is gonna be 0.4, as you can see here, and then the inner one, which is gonna be the one on the bottom, is gonna be 0.18. The degrees don't really matter. You could change that to whatever you like, but usually you want to keep that to the angle of the screw that you're using. All right, so we created the holes, as you can see. So now we could go ahead and start the simulation. So over here on the left, you're going to click on design, and you're going to go down to simulation. The study or the simulation that we're going to be using for this case is just going to be static stress. So it's going to be a constant force that you're applying to the model. So we'll just click on static stress and create study. From here, we have the toolbar that I explained to you, and we're going to be using this. So normally the way that you want to follow this is from left to right, because you want to go through all these, or until you get this pre-check to be a green check. In this case, we're not going to be using simplify, but in the other model that we have, we are going to be using it. So the material that we're going to be using for this body is going to be, all good? So the study material that we're going to be using is going to be aluminum 6061. So if you,
okay.
hey Alec,
I'm sorry. I was looking at what you're doing, and that's all.
yeah, no worries, bro. If you want, just if you aren't caught up yet, we're gonna start on the next sketch in a second, so don't worry about it. So yeah, so for the material, we're gonna click on material, and we're gonna make sure that it's gonna be aluminum 6061. I'm gonna click OK. So now it's giving that characteristic of the material that we're using. Similarly, if you do want to use, for example, PLA or ABS, if you're trying to print something on your printer, on your 3D printer, you could put those plastics and see what that the resistance and stress is for that thing that you're creating. So from here, we're going to create the constraints. Like I said, this is where, all right, there's an issue here. Okay. For the constraint, we're going to be putting where it is that the pressure is going to be on this model. In this case, we're using screws that are going to be going through these holes. So that's where the constraint will be. So we're going to click OK. Does Fusion simulate the infill if we want to simulate? Oh, good question. I don't, when I was using the ABS material, it didn't show me any of the infill characteristics. I might be wrong, but I have seen videos on YouTube where people have created models using the simulation. So I'm not 100% sure about that, but I could probably find out for you, and I'll let you know after. So now that we have the constraint, we're going to put the load. So obviously, in this case, we're going to put the load on the top. So it would be like as if you were having a shelf and you were putting a trophy on the top. So we're going to click on that top face right there. And we're going to make it be force. You also have pressure, moment, bearing load, and remote force. In this case, we're just using force. And then right here, instead of newtons, we're gonna be putting 800 lb force. So those are pounds, 800 pounds. For some reason, I don't know why it's coming up differently for me when I first did it, but it's same thing. You change the units to pounds force and put 800 if you have that little menu on the right. Okay, perfect. So press OK. And now we have the force on top, and then we're not going to use contacts because we're not using that. Oh, and so now we have mesh. So whenever we generate mesh, this is something that we have to do because whenever we do solve it, the program is using the mesh that we created for the model to determine what the structure of it is. But for a rule of thumb, whenever you have a block like this or a square like this, you always want to have at least two two that go on each side. So what I mean by that is when you go to mesh settings, you'll be able to change the amount of geometry that you're creating. In this case, we're going to put it to 50 or 5%. And then that's going to create a lot more boxes or triangles in this model. And that's going to make it so that the model is a lot more accurate since it has more triangles to calculate, like that. So from this point on, we are basically done. We could check to see that we have made all the requirements that we have, and we have. So now we could just click on solve. And so whenever you click on solve, it's going to come up with this menu right here. You could either use on cloud or you could use locally. I usually use locally just because whenever you use on cloud, I believe if you're not a student, it will charge you cloud credits, which I believe you only have a limited amount. For students, it seems like they don't charge you anything, but just to be sure, I usually just do it on local. If you do have a really bad computer, then I would maybe just use the cloud. But if you have a decent computer, then doing locally wouldn't be an issue. And you could name it wall mount or whatever you want. So now it's processing. It's going to take a few seconds. Yeah, this is a Fusion 360 workshop. So now it's complete. And now, as you can see, it shows us the safety factor. And it shows that the safety factor is a minimum of 0.79, which is really bad. We don't want that. What that means is that when we put that amount of pressure on the top, there's going to be some sort of break that's going to happen. But other than the safety factor, you also have stress. And with stress, these arrows right here, you'll be able to see where exactly that stress is occurring. So then you could maybe model the object that you're creating accordingly. You also have displacement. So the cool thing about displacement, it's a little bit hard to see because of the background. Let me change it back. Let's see if gray room. Okay, gray room is better. But you can see that it moved away from the original state. And something else to mention is that there's always going to be deformation whenever you're putting force on an object. And by default, it's always going to make it adjusted. But if you put it to actual, you're going to see that it's not moving as much as it's telling you to. But it puts adjusted so you can see the actual movement of it. And it also allows you to create animations. So on the top left, you could hit on animations. And then you'll be able to, if you change this to steps 30 and change the speed to fastest, as well as putting it two-way, once you click on play, you'll be able to see that deformation that's occurring for this object. And this might be if it's maybe required by your job, or if you want to do something cool, or see how it is that it's moving. But from that point, from this point on, like I said, the stress or the safety factor is really, really low. This is not something that we would be able to produce or sell or anything like that. But there's a problem here, and the reason that we're getting such a low safety factor is because the constraints that we put on this model are only on these holes, and it's not taking consideration the wall that we're putting it onto. So for that, we could add another constraint, and when we go to the constraint and look at types, we have pin and we have frictionless. Frictionless is the type of constraint that we put for walls. So for that, we're going to click on this space that's going to be, in theory, on a wall, and we're going to click OK. And then if we solve again, it's going to show us a different stress factor. And it's considering the wall in this case, instead of just having screws that are being held by those screws only. Yeah, so now you can see that the minimum safety factor is 5.28, which is okay, which is decent. So in this case, there wouldn't be any issues with this model. We would be able to use this, and there wouldn't be any breaks if we were to use that amount of force. But what if we wanted to make it even better? So I'm going to go ahead and ask you guys to see maybe what your idea would be to make this model even more structured, and see if you guys can figure it out. So what can we add to this model? What can we add to the geometry that would make it, the safety factor, go higher even more?
You could add a fillet.
What?
You could add a fillet to the edges right there.
Oh. So let me see. So you say adding it like here or here?
Oh, right there.
Yeah. That would definitely give it more structure, but what's something else that you could add to this? Any idea?
I mean, I was thinking like a triangle, like down the right there.
Yeah, you got it. Perfect. That's what I was trying to get. So yeah, you could add a triangle down in the middle, and it's definitely going to give it a lot more structure. So let's go ahead and do that. We're going to create another sketch, and we're going to create it on this face right here. So for that, we're going to use the 2-point triangle, and then we're going to go from the top of it, and then all the way to the bottom of it. Again, we're going to use the dimension so that we make sure that it's in the middle. I did that wrong. And then I believe it's 1.5. Yeah, so we're going to do 1.5 on each side. And that's going to push that in between those two circles, or those two holes. So from this point, we've created the sketch that we're going to use to create that support. And we're just going to extrude that up by 3.5 since there's 1.5 inches here on the side. Oh, we're not creating a cut, we're creating a join. So make sure you create a join and have that distance be a 3.5. But it looks pretty ugly. We don't want it to look like that. So what we could also do is create another sketch on the side of that and just cut that triangle off, so that we don't have any unnecessary material. So with the line tool, just create a triangle from point to point. And then once you create that sketch, just extrude it out. So for the extrude, you could always click here, cut, and then put the distance, or you could just go to the opposite direction of where it's pointing and it will cut that for you. Perfect. So now let's go ahead and try the simulation again. The constraints are still there, so we don't have to add it. All we have to do now is solve it to see how the safety factor is now. I did forget to put the mesh, but in this case, it doesn't really matter. I believe once you solve it, it does it for you. You just need to make sure that the settings for the mesh is correct. And our minimum safety factor is 12.26, which is a lot better than what we had, which was 5 last time. So it indeed, both the fillet and the support that we put here, it helped it a lot. So that's just an example of how you could use a simulation. Now we're going to have another example where we're going to be using a bicycle, crane arm. So if you click on the link, if you download that file that I put in the drive and open that on your Fusion, we'll go ahead and do a similar simulation with that, so you can see how a bike would react to force that's being applied to it by a human, for example. So let's see if we could have that show up. So I'll give you guys a few minutes to download that file. It's the bicycle crank arm. And in this case, we're going to be using that remove tool that we have within the simulation to remove these bushings that we have here. I also wanted to create this bicycle crank with you guys, but when I was doing it myself, it was way too long, so I didn't think we would have enough time, obviously. So yeah, now that we have the bicycle crank, what we're gonna do is we're gonna go to the simulation as well, again, and as you can see, we have these bushings, but we don't want to consider these bushings when we create the simulation. So what we're gonna do when we enter the simulation tab, we're gonna click on static stress again, and we're going to use that simplify tool, and from there we're gonna go to model components, bodies, and we're gonna click on those 2 bushings, and we're gonna remove them. Okay, so from this we could finish simplifying it and then add the material again like we did previously. We're going to use the same material, so aluminum 6061, and then we're going to create the constraint. In this case, we're going to be putting that constraint on this cylinder on the top here. I don't know why. Okay, yeah, so you click on constraint, we're going to put it on the cylinder on the top. So the force that we're going to be applying is going to be on the bottom, which is where the pedal would be in real life. So with that constraint, we're going to go ahead and apply the load. And for the load, we're going to go to this line right here on the bottom side of the crank arm. And you're going to click it on this. It's not going to be on the face, though. It's going to be on the line. And then from this point, we're going to go ahead and click on angle, because whenever you use vectors, it comes up with some issues. But in this case, it doesn't really matter. The angle that we're putting is on top of it, which is how a bike would react or would be used. And then the newtons, or first we're going to change the units to pounds horse. Now, let's say we have someone that's 200 pounds that's using this bike, and they're applying 75 pounds of force. In that case, it's going to be a total of 275 pounds that's being applied at this point whenever someone is pedaling. So we could go ahead and click OK. Let's make sure to generate the mesh for this model. And then from there, we can just go ahead and solve it because we see this green check mark here. We know that it's already ready to process. And then you're going to see something similar that happened with the previous model where you have displacement that's occurring. you're gonna have the adjusted displacement, and then you're gonna have the actual. And then we're gonna see how that displacement can change if we change the model as well. So as you can see down here, the displacement is pretty big. But in terms of the safety factor, it's 3.5, which is in green, so it's good. But you could always see what you could do to improve it. Maybe making it more thick, or creating more material within the cylinder. You play around with it and see what works for you. But like you can see here, you have the displacement. And now what we're gonna do is that we're going to see what happens if we were to hollow out the middle of it. Not completely, but only a little bit, to see if that displacement becomes greater, or if it lessens. So we're gonna click on Finish Result. We're gonna go back to Design. And then from this point, we're going to so we want to create that hollow part right here in the middle. We can't create it throughout the whole thing, because since this is angled right here, if we create it through out the whole thing, it's going to pass through it completely, and we don't want that. We just want to hollow it out by a little bit. So initially, what you're going to do is we're going to create a sketch, and we're going to place it on that same face. From here, we're going to use the project tool, so that we could have access to this line right here. Because whenever we're creating a sketch, I'll show you right here, we don't get an absolute like connection to this line right here. So that's what the project tool is for. Whenever you have a circle and you want to get the middle point of that circle, you use a project tool, and it will give you those points. So as you see, it gives me a point here and here, but it also gives me that line that I can attach to. So we're going to use the line tool, and we're going to just create a square within, or a rectangle or whatever, within that section right there. And as you can see, it's the plane is in the middle, so all we would have to do from there is extrude it the opposite way. But it's not letting me, right? And that's because the model is in the way. So what I could do is, whenever you don't want to include something, you just could put that body as invisible, and then create that extrusion there. Oh wait, why isn't it working? Oh, it's not connected. So let me create that line again. Make sure it is this time on that line. And now I should be able to extrude it. So we extrude it out. And now let's try to do the simulation with this model. We could also create fillets to maybe make it more structured. In this case, I don't think a fillet would be good, because we're taking away material instead of adding it, like the other one, like the other model that we used. So let's go ahead and just solve it again with this this model I created. And then after we're done with these simulations, we're going to go ahead and get into topology and the T-splines, so that we're going to be creating an Among Us character or the crew member, and then we're also going to be creating like an animal of some sort. The last part of this workshop is going to be interesting as well, because we're going to be using edge modeling. I'll go back to the presentation because I have missed a few slides in there, just because I've been going off the Fusion instead of the workshop. But I'll share with you guys the workshop as well, the PowerPoint, so you guys can reference it as well. So as you can see, the displacement is now 1.275, but I believe previously it was 1.0. So because we created this, or it was close to that, because we created this extrusion here and we changed the geometry, we're creating more flexibility or more displacement. Depending on the model that you're trying to create, this is an example of what you could do. Okay, so let me go back to, where is it? So let's see where we're at. So we have the results. We can use to compare the deformation, which I talked about, the mesh, manage, so you could change the settings of the load and things like that. and just inspect so you could see the stress and the displacement and all that type of stuff. We added the support, and now let's go ahead and create a drawing for the model really quick. We're not going to be doing it on this model, so we're going to be using the wall mount for the drawing of it. The reason I'm showing you guys this is because when and if you do get a job that requires you to make 3D models, they're going to ask you to do drawings of it so that you could have documentation of all the dimensions and stuff like that. So once you have the model there, hopefully you still have it. If not, it's fine. You could just follow along. You're going to go to drawing, and then you're going to go from design. Just click OK, since we have that model selected. And then this is where we're going to be able to place that model, add the dimensions, and create a PDF or a picture for anyone who may need it. At this point, you could change the scale to 1 by 1 so that it's realistic and it's a lot bigger. And then from here, you could use the dimension tool to get those angles that you're trying to, or not angles, dimensions that you're trying to get. So obviously you would want to have anybody that's maybe trying to recreate this to know what the diameter of these holes are so that they could recreate it as well. So that's just an example. You could also give it a different face. So if you click on that button right there, base view, and click on orientation, you could give it a home view so you could see the entire model. It is a little bit scuffed when you do try to get the dimensions of this because it's taking consideration the angle that the picture is giving it. But if we were to change it to the right, then we would be able to get that angle on the side, which is 0.5, basically. And that was that's how you create drawings for it. We did the bike arm simulation, some instructions if you guys want to follow along later with this. We also changed the geometry and saw how it impacted the displacement. And now we're going to go ahead and talk a little bit about topology and T-spline. So this is what you're going to be using whenever you are using the freeform tool. So these are all pre-made objects that you can then manipulate from the base object that it gives you. And most of the time, we're going to be using this modify tool to create what it is that we're trying to create. Symmetry, if you want to mirror the object that you're modeling. Utilities allow you to change the different views. So if you want it to be a box view, or if you want it to be more smooth. Constraint, we know what constraint is, things like moving the offset of the plane and things like that. Inspect for measurements, insert when we want to insert a picture, whatever it may be. So to talk to you a little bit about topology, what it is exactly. Topology is the flow of faces and edges on the model. So I'll get to what faces and edges are, but I mean, usually it's pretty common sense. Faces are the faces or the shapes, I guess you could say, of the model, and then the edges are the lines that are connecting to it. But with topology, you have different flows with different results depending on the design that you're trying to create. You use topology so that you can get a cleaner result with the surfaces for the design intent. And then some terminology for you to know. There's edge loops. So edge loops are a continuous group of edges. Face loops, continuous groups of faces, and then rings are the edges between the faces and the face loops. So all this stuff is important when it comes to using topology and using the T-spline because it makes it so that your model is a lot more smooth and structured. I forgot to mention, there's also box models and edge models. We're going to be doing 2 models with the box model method, but we're also going to be making one with the edge model. I would say that box modeling is a lot easier than edge modeling, and you'll see why when we get to that. But yeah, some tools to consider here, similar to how we have here face loops and rings. We have loop growth and ring growth, which will get those loops from your model and shrink it or grow it. And then for the edit form tool, which is going to be the main tool that we're going to be using, it allows you to move the faces, the edges, and vertices. And if you hold down Alt or Option, if you're on PC, then you can use Alt. If you're on Mac, you use Option, and you'll be able to create geometry, or you'll be able to extend that geometry that you have there. And I'll show you what I mean in the next slide. But for the most part, the tools that you're going to be using, and it's a lot easier and more basic, are going to be the edit form, the insert point, and the weld vertices. We are also going to be using the merge edge, but that's going to be for that last sketch, which is going to be a little bit more difficult, and you'll see what I mean. But let's go ahead and start practicing with box modeling. So we're going to try to recreate this model right here. It's some sort of cat or dog, but you can create it as you like. This is just practice, so you guys could get a sense of how box modeling works. So let's go ahead. Do I need anything here? No. So let's go ahead and create a new design. And then I'm going to pull up that image so that we have it here for reference. So at this point, what we're going to want to do is we're going to create a form. And then we're going to create a plane. And we could just click any plane. And then we're going to go ahead and make it 1 by 1 inch. Okay. So from this point, something else to mention is that whenever you do create a plane, it's going to ask you the amount of faces that you want. I'll do it again so you can see. And then, as you can see here, we have length faces and width faces. If we were to change that to 3 and 3, you will see that the faces on this plane have changed. And what these lines allow us to do is give, it could be a blessing or it could be something bad, because if you use it, you're trying to create more detail in the model that you're creating. In this case, we're just going to go ahead and use 1. Because once you do add more faces, it tends to be a little bit more complicated in terms of the connections that you're making. But from this point, you go ahead and hit on edit model. And this is going to be preference for me. If you want to follow along as well, I put the plane on the wrong axis. It's a lot easier for me to put the plane on this axis. So if you want to press Control Z and go back to the plane and click on that, I would recommend it, because I mean, for me at least, it's a lot easier. So 1 and 1, okay. We're gonna edit form, and then once we edit form, so let me show you what I mean by what you could do with edit form. So with this pane right here, if we click on edit form, it'll give us this editing tool. So with this, we could move the plane, scale it. We can change the point. We can also extend the edge. What we're going to be, and also, like I said, if you hit your Alt or Option key, it will create geometry from that plane, as you can see. So that's how we're going to create this cat or dog over here. So what you're going to want to do initially is, once you have that plane, you're going to click on it. You're going to hold Alt, and you're going to drag that out a little bit. From this point, since we want to use symmetry, because with symmetry, we're able to create a more structured model instead of having it be one side different than the other. So from this point, we're going to use symmetry. And for the symmetry, you have 2 main tools that you're going to be using, either mirror internal or mirror duplicate. Mirror internal is whenever you have a model that you've already created and you want to continue, or you want to add some symmetry to it, then you would click mirror internal. Whenever you're initially starting a model, you would use mirror duplicate, so that the initial creation that you're making is following it. So like from now on, this model is going to have symmetry, and whatever we do to one side is going to do to the other. But if we don't want that to happen, then we have to make sure that we select both sides. So as we can see from the dog model over here, we're going to act as if this is the nose. or the eyes around here. So we're going to click on the back of it. We're going to click on both sides, and we're going to hit Alt. Or first, we're going to hit Edit Form, hit Alt, and pull that out. So from here, we're going to go ahead and create the ears. Now, since this is symmetrical, or since we have symmetry here, all we have to do is click on one of those faces. And again, we're going to hit Alt, and we're going to drag that up. But you don't only have these arrows to edit them. You also have these. These are a lot more free. They allow you to move it in any direction that you would like. And then this allows you to scale it down, up. If you click on the side, it'll make it more narrow, and in the all directions as well. So I think I'm satisfied with that. Those look like nice ears, I guess. But so now we're gonna go ahead and create the rest of the face. So we're gonna click on both the faces on the bottom of that. We're gonna click on Alt, and we're gonna drag that down. And then let's create the mouth. So the mouth is coming up from these two. So we can hold Shift, click on those two faces, and drag that out. And as you can see, it's pretty easy, but once we get to edge modeling, you'll see that it could get a lot more difficult. So from this point, we can, so from this point, let's go ahead and create the neck. Let's bring that down again. And I kind of want this to be a little bit more wider. Maybe not that wide, but I want it to be wide on this side, like that. And then now let's create the back. We click on those two faces and just extrude backwards. Another thing to mention is that whenever you do hold Alt and you create that that object, whenever you unclick it and do it again, is going to create another line. And these lines are pretty important because you want things to be symmetrical. And I'll mention something now. The issue with whenever you're using box models is that these lines are created by themselves. But let's say the structure of the mouth isn't something that we want. What we could do is add lines or add points here that are going to change the structure of this mouth. And when you start using more complicated models, this could be a little bit annoying. So from modify, you could hit on insert point, and then let's go ahead and structure the mouth of the dog or cat that we're using. But remember, we're using symmetry, right? So since we're using symmetry, why isn't this working? Since we're using symmetry, we just need to use it on one side. When I first, I missed that point right there. And then let's click OK. And as you can see, it created a mouth, or a more structured mouth, because we added those points and added those lines. And like I said, this could get a little bit more complicated if you have a model that's a lot more complicated than this. But okay, let's go ahead and create the legs. So for the legs, since we have a symmetrical, we could just do one face and it'll copy that. And let's go ahead and move those legs a little bit out. I don't like that. There you go. Let's create legs on this side as well. Oh, just one face. Make sure you hold Alt. And let's move these legs a little bit out so it looks more natural. All right, so the only thing we're missing now is the tail. So we could click on those two faces right there and just extrude that way. Oh, what happened here? Seems like these are selected as well for whatever reason. Okay, and the tail usually is a lot more narrow than this. So let's use these on the side to make it a little bit more narrow on the side as well as on the top. And there we go. We made a cat or dog or animal. Pretty cool. So that's so you guys could get a little bit of practice in terms of how box modeling works. I gotta go. Thank you. No problem, Brian. I'll see you around. See you, Jeffrey. I didn't see your guys' message. Oh, he's already out. Okay, so from this point, we could just go ahead and click OK. We're done with this model. Let's go back to the presentation. Where is it? Let's see what's next. All right, so unfortunately for those people that had to go, we were going to create an Among Us character, which is pretty cool, I guess, since Among Us is the trendy thing right now. But this is again recorded, so for you guys that are watching this, this should be pretty cool. And for you guys that are here live, hopefully you follow along. But for this, go ahead and download that image from the Google Drive, and we're going to be using that image as a reference to create this model. So how we're going to do that is we're going to go to Fusion. We're going to create a new design. And we're going to, I'm out. All right, see ya, Natalie. Thank you for coming. It's only you and me. No, I'm playing. But yeah, okay, so let's continue. So we're gonna create a form, and then once we create or we click on that freeform tool, we're gonna hit insert, and we're gonna insert the image of Among Us that we're going to use. Just click a plane and click OK. Now this Among Us character is really small. We want to increase it to maybe something that's more realistic. Let's say, for example, you wanted to print this, which is something that I actually was trying to do, but my printer is having some trouble issues right now, and I didn't really have time to fix it. But I'm definitely going to print this model that I made once I get that fixed. But yeah, so in order to scale this up, we're going to click on canvases, which is where the picture is. We're going to right click on that. Sorry, my ears are hurting. We're going to right click on that image, and we're going to click on calibrate. And what calibrate allows us to do is pick the point of the model and give it a certain length. So I want my character to be 2 inches. So it'd be 2 inches in real life, which would be a good size. And then from here, we're going to use the quad ball as the base of our model. And we're just going to click on the same plane that our character's on. We're going to scale that up to 180, I think would be good, or 170 is a good amount. And then from here, we're going to start morphing this ball to the shape of the crew member. So we're going to use the edit tool, and we're going to click on these 2 top edges, and we're going to move this up. We're going to go a little bit higher, and then from here, we could start moving it little by little. So just click on it with the edit tool selected, and you'll be able to change all these points. If you want to be a lot more structured, then click on the actual points instead of the lines, and you'll get a lot cleaner line. So ideally, this black part right here isn't going to be necessary because the body of Among Us isn't 2D, or we're not creating a 2D, we're creating a 3D one. So the visor is going to be in the front of the face. But now let's go ahead, move this a little bit higher, and let's create the legs. So we could use this, and we're going to hit Alt or Option, and then we're going to create that leg. I don't really like how that looks, so let's just use that bottom face. Yeah, perfect. I like that a lot better. And then from here, let's manipulate the lines so it follows the model that we're using. Again, we're going to do the same thing on this side. Whenever we're creating more volume, we hit Alt. I don't really like that. I think in this case, best thing to do, yeah, I don't like that either. Let me extrude that, or actually let me increase that a little bit. Yeah. And let me hit that line right there and move it as well. I think that's a lot better right there. Okay, so let's try to do this other leg now. Like I said, I don't think it's gonna work out because of this point right here. So maybe I could move that point more to the center. Yeah. And then from here, if I get this face, I hold Alt. Perfect. That's a lot better in terms of what I'm trying to look for. Let's make sure we're front facing. And then now let's start to put it in the same form factor. Again, this doesn't have to be perfect. You do yours best you can. Everyone's different. And now this is also the backpack. So we basically got the body of the character now. So now we have to create the visor. Sorry. So for the visor, let's go ahead and use another quad ball. So for the quad ball, same on the same plane, and then we're gonna increase that quad ball. We can't see it right now because it's inside this one. So let's go to bodies and make that initial body invisible, and then we'll be able to see about what size we want. Let's move this. So if you want, highlight that, and then you could hit the M button, and you'll be able to move it to where it is that you want it. So it doesn't have to be exactly, but we could kind of use it as a reference. And now with that there, let's go back and put this back to invisible, or visible, sorry. And let's move this again a little bit forward so it's protruding the other body. And we're getting that sort of look that we're trying to see. Yeah, so one thing that I see looking at it from the side is that it's way too thick, it's way too fat. So let's put this, first of all, let's just move that there, and let's put it invisible, and then let's make this body a lot more thin. So we highlight the middle of it, we click on modify, and we can use this scale right here to make it a lot slimmer. But I feel like the top is messing up as well. So let's make sure that that's also being considered. I don't like this right here, so let's push that a little bit more in. Maybe let's make this, sorry about that, let me mute really quick. And all right, I think I'm happy with this. So let's go ahead and make that other ball invisible. I'm liking how it's looking right now. We just have to change the shape of it. So let's put the other one invisible, and let's start to shape this to the visor. So same way we did it with the first, just click on what it is that we want to change and move it to what it is that we're trying to do. Okay, let's see how it looks with this. So let's move it back because I feel like it's way too forward. Or we could just scale it actually. Let's do that. Let's scale it because I think it's too big. So to scale it, you just highlight the whole thing, or you could also click on the body. Or you can't click on the body, but let's just highlight the whole thing, and then right here in the middle, that's the complete scale, and that will scale it to be smaller. Didn't scale this, so let's scale this as well a little bit. All right. Again, this isn't going to be perfect. Everyone's going to be doing it differently. For whatever reason, my initial design, the one that I did first, the first time, came out perfect. All right, I'm happy with that. So let's look. Oh, I am not happy with that. Let's move this a little bit to the right. What happened? So let's go ahead, move this to the side and up. And I'm just gonna go ahead and leave it like that. I think it's decent. But I'll show you my first design, and it was pretty good. But now the only thing that we're missing is the backpack. So let's go ahead and create a box. We're gonna click it on that same plane, and it's inside that. So let's go ahead and move this out. Oh, what happened? Oh, I think I know what happened. Okay, so let's just click OK, and then we're gonna move that a little bit back. So click the M button, move it a little bit back, a little bit up. Let's put the body back into place. I think that's a good position. I like it. All right, and then let's look at that. We basically got our crew member. He's not the most handsome crew member, but it's decent, you know. And then now we're going to go ahead and just add color to it. So with our bodies made, we're going to click on each body and click on appearance. We're going to make this guy red. So let's make the body red and the backpack red, and then the eyes are going to be a glossy white. Now if we deselect our canvas, it's definitely a sus Among Us character. But if you look at the one that I previously made, it was a lot more decent. I don't know why this one came out prettier, but you know, every time is different. Anyways, so that was the Among Us character. I hope you guys are able to follow along with that as well, and maybe made your own weird characters as well. But now, let me talk to you a little bit about edge modeling. It is, and for me at least, is a little bit more complicated or difficult. But some tips that you guys could use is whenever you are using edge modeling, make sure that you determine what the defining details are. Make sure that you have your initial face loops, and then make sure to create those mesh densities, how we did with the simulations. And then we'll be able to fill those gaps so that we could create the complete model that we're trying to do here. And so yeah, this is the last sketch that we're going to be using. We're going to be doing edge modeling with this, which is a little bit more complicated. It's not complicated. It's just, you'll see what I mean when we start it. But we're going to insert the image. We're going to I gave you guys also an image of a faucet on the Google Drive. Just go ahead and download that. We're going to do the same thing that we did with the Among Us character, with the crew member. And yeah, so we're going to create a sketch from it, and then we're going to mirror it so that whatever happens on one side is happening to the other side. Makes it a lot more easier to follow. We're going to build the faucet, and then we're going to be adding faces, deleting lines, points, and then merging the edges and welding the points. Right now, you guys probably don't know what I mean by this, but once we start, you'll see what I mean. So go ahead and make sure to download that faucet that I gave in the Google Drive. Let me open it as well. We're going to insert it. Here it is. Let me close this right here. We're going to click a plane, click OK. And again, we're going to calibrate it so that we can create a size that is more realistic. So a sink, normally I would say it was probably about 10 inches. So you could put 10 inches, zoom out. Now we have sort of the canvas, or that we have the canvas that we're going to use. So from this point, we're going to create a sketch. So for this sketch, we want to have it be cylindrical, or it's going to be on that plane. on the plane that's lower from that. But the canvas is a little bit lower, so let's go ahead and move that up. Let me see if I can move it. Yeah. Is it going to allow me to move it? It should have. Let's try it again. So from here, we click on move, click. Let me see. If I right click on here, edit canvas, there we go. And let's make sure we tell it what plane we're using, and then let's move that canvas up. Okay, anyways, we got it pretty much there. So now let's go ahead and create a line on that plane. Just a regular line, because then we're gonna be we're gonna mirror it over the axis. So from this point, we're gonna create a form, and then we already have that line there. So let's make a construction line in the middle so that we could mirror it over. Now, like I've said, this is, for me at least, it's a bit difficult. I was able to get it, but we'll see how it goes for this try. So at this point, what we can do is finish the sketch. We're gonna mirror it over that line that we have. But first we have to create the body from it. So click on create, click on extrude, and we're gonna click on that line. And then if we increase it, what's happening? And as you can see, that's the edge modeling that I'm talking about. So right now we have 15 faces. Let's just go ahead and lower that to 3. The faces are very important when it comes to creating these models, because that's the way that they connect. And you'll see what I mean. So from this point, we're going to use the duplicate mirror. We're going to click on that T-spline body, and then the plane that we're going to be using it is going to be over that axis. So the construction line wasn't necessary, but it's okay. So that from this point, what we're going to want to do is create that general shape of the faucet, of the bottom part of the faucet. So similarly with the box modeling, you click on the point, you're going to have access to modifying it. If you hold down Alt, then you'll be able to create stuff from it. Now, that's what I mean when I say it's a little bit weirder when it comes to edge modeling. Let me put that canvas invisible. When you are using the edge modeling, you have to make sure that you understand the direction in which it's going, why for me, whenever I am using this, I tend to use the arrows a lot more because it's a lot more structured. Whenever you hold down Alt again, it does create those lines. And like I said, those lines are going to be pretty important later on. So I think 2 on the side is fine. So let's just go ahead and go right again. And we'll try to resemble the side right here. So we have 1, 2, 3. So we'll do 1, 2, and then this last part, we'll leave it like that. We'll click OK, and then we're gonna merge that together. The way we're gonna merge that is with weld vectors. So we click on the points that we want to weld together. Perfect. So now that we have this, we're gonna use this body so that we can copy it and create a more smaller top part of the faucet. So if you've ever seen a faucet, which you probably have, it tends to go, it's like sloped up. So from here, we're gonna scale it down. And how we're gonna do that is just clicking on the body, hitting on the modify button, and then using that middle one to scale it down a little bit. Not too much, because we still want to have that connection there. But something about this one specifically is that this part of the faucet is going to go up. So we don't want to have these two faces here. So now we're going to create the head of the faucet. So we're going to click on edit form. And we're going to hit on that. We're going to deselect the body because we just want the edge. Why is that happening? That's weird. That is so weird. I've never seen that. Oh, there we go. Okay. So now with that edge selected, we'll go ahead and start building it upwards. So hold Alt and start building it upwards. We want that angle to stay straight. So as we go up, we'll start to change that angle so that it's more direct or more perpendicular. And you'll see how this is ultimately going to create a faucet. So now continue to hold Alt and go up. And like I said, we want these lines to be similar to each other because they're going to be the ones that connect. So I think that's high enough. So maybe too high. I think there's fine. So from this point, we're going to go to the right. And then we're going to go in more because that's how faucets. But we don't want to use that one. We want to use the one that's right on top so that it doesn't move. Because like, for example, if I were to go like this, you can see it goes down. Because orientation, we're not really looking at the right orientation. Whenever we want it to stay on the same plane, we use that tool that allows us to do so. And from this point, we want to start to angle this so that we can connect it. And go like this, go like that, keep going. And I think from that point, we could probably weld it together. So hit on modify, weld vertices, weld that, and we keep the structure that we're trying to get. Now these gaps right here might be an issue because they're so far apart, but I think we could probably manipulate this later on if need be. So we got the basic structure of it using edge modeling. Only thing that's left is the top part of it. So now we're going to create another sketch. But for this sketch, we want to have it be an offset. And the reason we want it to be an offset is because we want it to start at this point. So we could offset it to 1.5. And then from this point, we'll create the line that we're trying to get here. So click on create sketch. We're going to create a line. And then just create just like a normal line. It's nothing special really. But we're also going to mirror this as well. But like I said, for the first, or when we did it for the first time, we have to make sure we create that T-spline body before we can mirror it. So since we need to create that T-spline body, we need to hit extrude, and it's going to extrude this line up. This is going to be one face because since we're going up, we don't want it to have faces on this specific plane. So now that we have that there, we could create a symmetry that duplicates over the plane. Okay, cool. At this point, all we have to do now is start to model this up. And again, once we get closer to the top, we can start moving it to where it is that we want, start angling it in the orientation that we want to get. Don't go too crazy with it because then it will give you errors. So just, yeah. So from this point, let's see how we could do this. I would say maybe try to angle it a little bit more, and then use maybe this one right here. So you could get that sort of, yeah, perfect. So angle it again, make it straighter. Oh, what did I do? And you'll see what happens at the end when we merge all this together. It creates the faucet that we're trying to get. Angle, perfect. And now we could just continue to extrude out this line. So for that, hold Alt. Oh, I think I have an issue that I just realized. I wasn't counting them, but I think it's fine. Okay, cool. Yeah, so you always want to make sure that you're following along with these faces, because those are the faces and the lines that are going to be connecting everything together. If you don't follow that accordingly, then you're going to have a real issue when it is time to put things together. So let's make this a little bit smaller since we're all the way up here. So let's do that. Let's continue to go closer. Let's move it up a little bit. If I could click on it. And then now let's try to merge that together. How should I get this? I think best way possible would probably be, yeah. Bro, practice, bro. Like, this stuff really takes some practice to get used to how it works. It was not easy first time trying to do this. And we're almost done, so. Let's see if I could do this correctly. Shorten this more, and now we want to connect this. So we could use this one right here. Change the angle on that, and I think we could weld that now. Okay, perfect. Oh man, I can't believe I did it. I mean, shouldn't say I did it yet, because now we have to merge everything together. Okay, so now we're gonna merge edges, and then we'll be done. So we're gonna go click on Modify, Merge Edges, and we're gonna click on all of them on the first T-spline that we created. If you double click on the line, it will click all of them together. So as you can see, we have 16 selections. And then for the group 2, we could click on these as well, but we don't want to have these included because that's not what we're trying to merge together. So we hold Select and click those out. I think you have to hold Select. Oh no, you don't have to hold Select. So you could just click those or deselect those so that they're not being considered. I wanted to create a car with you guys, or like the shell of a car, but it was way too difficult. And now if we click, why do we have 1614? Oh, because these two right here. So I think maybe I should deselect these as well. Yeah, okay. So from this point, we have this hollow part right here, so we're gonna go ahead and extrude some of these lines out. So we can just click on that, click on the modify, and then start to extrude that. Again, make sure that you follow the faces. If you don't follow the faces, it's not gonna create a correct model. But I think this is gonna have issues for sure. This one right here. So maybe what we could do is, yeah, I know what we could do. Do this. Create that there. Okay. So now let's start welding. So hit on Modify, Weld Vertices. Let's put that one there. Put this one here. Yeah, that's not gonna work. Okay. let's first deal with this. Why can't I turn it? So let's start welding these. Whenever you see that the model becomes more blockish, there's something that's going wrong. But you want to make sure that you, why doesn't it turn? Okay. You want to make sure that you include all the points and you're not forgetting any, because if you do, then you're going to have that issue where it becomes a block. Okay, so what am I going to do here? Okay, so I could maybe click that together. Yeah, perfect. And as you can see, while I do one side, it's automatically doing the other side because of that symmetry that I have there. So let's go ahead and weld this. Yeah, so we can't weld that like that. So what I would do, let me start welding these first. And then once we get to that last part right there, we'll figure that out. I think we could weld this with this. No, I messed up. Okay, so for now, let's just leave that there. We'll deal with that later on. Just keep welding all the points. It's a lot easier this way because if you do it with the merge planes, you'll start getting issues, and we don't want that. Okay, so right here, make sure you weld. So I think one issue that I forgot is adding these vertices together and adding these as well. Yeah. Perfect. Okay. So I definitely have some issues on this one right here. But I think what I could maybe do is, let's see. If I create a face from here, extrude this out a little bit, put this point, move it down. And then let's try that. Let's try welding those. Oh, almost there, almost there. It worked. So it's not the most beautiful sink, but it's a sink, that's for sure. And we are well, let's leave that because that's where the water exits, right? And we'll just go ahead and say that's where the water comes in through. I don't know. Or it's just the design. That's the design that we made. Like it or don't like it. But there we go. We created a sink with edge modeling. Kind of don't like this part right here on the top, which is the good thing about using these forms is that we're able to modify this as we like. So if we want to make it bigger, make it smaller, we can. But yeah, that's basically it. Hope you were able to follow along. Like I said, edge modeling is a little bit more complicated and a little bit more difficult, but with practice, you'll be a lot more comfortable once you start to understand that you can manipulate all these lines and all these points to do whatever it is that you want to do. It'll be a lot easier for you. And yeah, so let's go back to the presentation. So we created simulations with a wall mount. We created a simulation with a bicycle crank arm we also created an animal with the box modeling. We created an Among Us character with the box modeling, and we created a faucet. This is the faucet that I made the first time. As you can see, it's a lot better than the one that we just made, but every time is different. So it might have been different for you, but as long as you got the concept behind it, that's the main point of it. With that, I want to thank you guys for watching. Thank you guys for coming, especially you, Mitchell. Thank you for staying here the whole time. And yeah, we are Epsilon Pi Epsilon, largest tech organization at FIU, and this is the Make program. So hope you guys enjoyed it. Yeah, no problem for you, bro. I appreciate it. And that's the workshop. So if you have any questions, make sure to let me know in the comments or DM me on Discord. Or if you have any questions right now, Mitchell, you could ask me. If not, then it's cool. I think it was a good time though. 1:30, 1 minute or 1 hour 30 minutes. Not too long. So awesome. Anyways, thanks again for coming, Mitchell, and everyone who's watching the workshop. If you want to get credit for the attendance, make sure to follow along with the workshop and send me proof that you did the workshop yourself, and you'll be counted for that. Or actually, yeah, I'm gonna do that because since it's midterms, I don't want to remove that attendance from these people. So if you are willing to do that, go ahead and let me know. I'll go ahead and end the work.